In this video, I'm going to demonstrate how to create a generic template class. A template class is a class that can hold any data type. You'll have a member variable inside the class that's generic, and you can pass in a string, a double, float, string, whatever you want. They are easy to set up, but they're a little different than you're used to with classes. So I'm going to use, again, our Alt-X tool and create gen class. So you've got our standard gen class and gen class HVP. Unfortunately, these generic classes cannot be split across two files, so I'm going to just split them in one, which means I'm going to delete my gen class CPP. Everything has to be done here in inline. I'm also going to get rid of this destructor because we never use it. So now I've got this class set up. And let's add some data in here. Like I do with my template functions, I'm going to create template class C. And I'm going to use that down here in my private or my protected section, whichever you prefer. C will become any data type you want. So I'm going to create a variable called the value. And I'm going to create a variety of inline methods. Here's my default constructor. So I'm going to set it to some type of variant of null. I need setters and getters. I need a parameterized constructor. I'm going to do them all here in my H. And everywhere I would need a data type, I'm going to use C. Drop void. And this is just basic, setters and getters. And anywhere you need a data type, you put C. Here's my setter. Why are you still angry? I'm not sure why that's still angry. We'll make that go away in a minute. That's doing. I'm going to delete this if not defined, this pound define, just to save me an error. Oh, no, I got a new error. Great. All right, let's go to our main. Let's pound include this thing. See what happens. Okay, so now what this allows me to do is allows me to use this gen class and hold anything. Now what I have to do differently, though, is I have to define what C stands for. I'm using the angle brackets to designate that C shall be a string. And I've got setters. And I get a warning in converting, which I don't care about. But you see I got my answers back. Still have the error on Pragma, which shouldn't be an error, but I'm going to ignore it. But you can see I can pass in any data type I want. I use the angle brackets to determine what the data type shall be. And then once this is here, the string gets passed in the gen class, and then C becomes string. Likewise, down here, double gets passed in the gen class, and C becomes double. If you have any data type you want, even your own built-in classes can be used here. Now, why this is so important. Creating a generic class variable can be very helpful if you have a variety of different data types you're getting from your users. So if you're reading from a file and you have no control over that file, and sometimes they're int, sometimes they're double, sometimes they're floats, sometimes they're strings, this will handle that. But secondly, when we move forward again to the C++ standard template library, you'll see this structure all the time, and it's simply defining the data types that are inside of that template class. All right, so good luck to you, and have a good day.